Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Anas bin Shahma, and today I will present to you our mini project, which is analysis of DC-DC boost converter circuit. My other friends is Muhammad Shazwan and Song Kayun. First of all, I will introduce to you about what is power electronic converter is. Power electronic converter is a power electronic circuit which it convert a type or level of a voltage or current waveform to another form. For example, we can take is chopper, which is it convert the unregulated DC voltage or input to regulated DC voltage, which is output. And this chopper divided into two groups, which is done isolated and isolated. For example, that we can take is non-isolated, we have buck boost and buck boost. Meanwhile, for isolated chopper, we have flyback, forward, push-pull, and full or half bridge. These boost converter are often used in electronic to provide a DC output that is larger than DC input voltage, hence increasing the supply voltage.
The circuit operation of DC-DC boost converter has two modes. The first mode is when the switch is on and conducting, the diode is off. When the switch is turned on, the initially high frequency square wave will apply to the pulse generator at startup. During this time, a short circuit happens at the right hand side of inductor. The output capacitor stays charged since it can't discharge through the left hand side due to the back bias diode. Therefore, a current flow between the positive and negative supply terminals through inductor, which store energy in its magnetic field. The second mode is the switch is off and conducting, the diode is on. The current to the inductor is stopped abruptly. The inductor now acts like a voltage source in series with the supply voltage. The inductor generates a large voltage with the opposite polarity of the voltage originally supplied to it using the energy stored in the magnetic field to maintain the current flow. The anode of the diode is now at a higher voltage than the cathode, which means it is forward biased. The output capacitor is now charged to a higher voltage than before, which means that we have successfully stepped up a low DC voltage to a higher one.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shazwan, and now we want to discuss about the verification through experimental result and calculation. And this is the and this is for the parameter and the value that we must consider in the project. So my group has choose 80 kilohertz as a frequency and a duty cycle as is 0.8. Okay. Now this is for the simulation part for the duty cycle signal, which is we can get from the bus generator. Okay. This for the simulation for voltage, which is we can get the underdamped response, and for the output voltage we can get from the steady state response, which is at the steady state response we can get for the output voltage waveform. So if we zoom in, and we can get the output voltage ripple, which is this is for the output voltage ripple. So this is the ripple here. So okay, then this is for the inductor current waveform, which is similar with the previous one. So but this is under the response, and we can see the inductor current at the steady state response. So if we zoom in, we can get the maximum and minimum inductor current, or we can see at the at here we choose for the trace section, and then for the max and for the minimum. Alright. Okay, now we want to see for the calculation part. So for the output voltage, where we can get from the this equation, which is V in divide by 1 minus D. D is the duty cycle. So this is duty cycle where we can get the output voltage is 250 volt, and then for the output voltage ripple, this is the equation that we must follow, which is duty cycle multiplied by the voltage output voltage, which is this output voltage. And we divide by the resistor, capacitor, and frequency. So and we calculate, then we can get the output voltage ripple. And then for the inductor current, we have three calculation, which is first for the inductor current, and then for the minimum inductor current, and then for the maximum inductor current. So for the inductor current, we will use this equation, and then we can calculate, and we can get the answer for the calculation part. So for the minimum inductor current and maximum inductor current, what is the difference between these two parameter is the minus and plus, which is the plus minus for the in the equation. So then we will use this equation, which is V in divide by 2 minus this is duty cycle and square, and then multiplied by R. Then minus V in multiplied by duty, and this T is period. So this period this T. So then we calculate, and then we can get for the minimum inductor current, and same for the maximum. We calculate same as the minimum part. So you can get for the answer for the inductor current for the max inductor current. Okay. Now after we done a calculate and measure or simulation part, so we must compare between these two terms, which is a measure value and the calculated value. So for the we can see the output voltage, we can see between this difference, and then output voltage ripple difference, what is the error between these two, and then the inductor current for the measured value and calculated value, and then for the inductor current for the max, and then for the minimum. So we must compare between these two calculation part and measured part, which is from our simulation in MATLAB.
And we have come to our conclusion. So first, for the conclusion, we can conclude that now we have been able to explain the significance of using gate driver for converter circuit. Next, we also study that duty cycle pulse signals are generated by comparing the DC line with similar amplitude and the sawtooth signal, and also understand the principle of operations of boost DC to DC converter circuit. And now, lastly, we have been able to analyze the boost DC to DC converter performance under variations of parameters that have been used. For examples that we use is 80k Hz of frequency and 0.8 duty cycle. And that's all from us. Thank you and stay safe.